So I've been building a few of these little electronics kits I've been getting from China and from eBay, and I decided on this occasion I wanted to get one from Banggood. Now this is a little oscilloscope. I do have an oscilloscope, but it's this big. I found this little one, and what I liked about it was that it came in its own little box. Not this box, it came in its own enclosure. So let's see what it's like. That's good. Some probe leads, that's useful. And this, a lot of the things you get from Banggood come with, well, from eBay, come in little sets like this. You don't really know what to do with them, but this is much more like a proper kit. What's that? So that's the LCD screen. Get that out. There you go. Nice little screen. Oh, and controller board there. Another controller board. Come back to what these do. This has got surface mount chips on it already, which is a good job. I didn't check whether it was surface mount beforehand, so I'm glad. So I don't have to attempt to solder those on. Use a manual. Oh, pretty nice soldering instructions there. Pretty good build instructions. Very clear. This is much more like a... Oh, that's interesting. The manual actually tells you how to solder on the surface mount chips, which I don't have to do. So that's good. And you see the case there as well for it, which hopefully is in the bottom. There you go. It's this cute little case for a oscilloscope. And the parts there. So this looks quite good. I'm just going to null out all the parts and then think about getting it built. So there's two parts of the user manual. There you go, step 3 to step 6. And then the first one, step 1 and 2, and, well, yeah, I don't know. So at the top is a warning saying that we strongly recommend that you put the SMD devices on beforehand. Thank goodness I don't have to do that. So here goes. So the first thing it tells you to do is to connect something to the main board. Check the display works, check the buttons work, and apply power. I'm going to have to solder the buttons in as well, but let's see if I can get it to power up. Now it wants 9 volts. Let's set me 9 volts on the meter. I'm not sure. This is where the whole thing blows up, but anyway. Aha, there you go. Well, it lights up. Oh, there you go, and it's booting. Excellent, right, so it does work. So it talks about checking the buttons first, but the buttons are already, well, the buttons aren't on this, so let's insert the buttons and solder them in first. And move this other stuff out of the way now. Okay, I don't like this LCD flapping. Right, so there's the buttons in. Oh, there, and it says on the instructions, do this after the buttons have been installed. Okay, alright, so now test signal terminal. Before soldering, bend the terminal to the shape shown in the left photo. Right, okay, so it wants me to bend these two up first. Right, let's get something to bend those with. This should do. So there, bend one up, and bend the other one up. Hopefully those will fit through the holes now. Test signal terminal. Okay, well, on the instructions it says it's on J8. So J8 is there, right. And okay, hopefully that should go in there. Now I assume it goes on the top of the board. So let's just solder that up. I'll just pop that under there just to keep it up and to provide a wonderful heat sink so that the solder won't flow properly. That's 2. Doesn't look like a wonderful connection there, but right, now 3 is power connector optional. Why would power be optional anyway? So there's the J3 connect. Oh, where's that come from? Probably somewhere important. Right, the power is there. Okay. Now this looks like it's on the back of the board. Right, now I can work this out, can't I? So if that is the power, it's going to be there. Then the power connector. Oh, I wonder if that's a power connector for inside. I think it is. And maybe I can have power internal, which would be good, because it doesn't look like it's got a power socket. And it looks like that's on the top of the board, which means my earth connector's in the wrong place as well. Right, okay. So that didn't last long, so I need to whip that off. Okay, that's then clean. And each time I pick this up, I forget there's this little screen on the bottom. The screen's soldered on, so I can't remove it. I'm going to have to refer to the pictures on these. So it says the next thing is to put this in, which is weird. I would have put all the resistors in first, but let's follow the instructions. So that goes there, optional. All right, hopefully I did that bit right. So that's the power connector. Okay, so then the next thing is the slide switch. The 2 switches. Oh, the tack switches. Wants me to do them afterwards. Anyway, right, let's carry on. Pin header male, junction 2. Oh no, I don't want the pin. I want switch 5. double pole, double throw. Now which is which? Well, looking at the picture, it's this one, and that goes into switch 5. It's the first time I've ever soldered in one of these switches. Interesting. Oop. One of the pins was bent out. I hadn't forced it in yet, so it must have been like that when it was in there. So I will solder the shell in first. One side. That's the other side. Okay. Now we've got to put a header in. Oops, and that goes in junction 2. And I also have to take this out because I put this in the wrong way as well. Well, it did say this was optional. I wish I'd left it out. Remind me. It's on this side of the board from now on. Okay, so now we have the jumper, which was the 4-way jumper. It looks like it could be there. Yeah, so this looks like it's needed to connect the rotary mechanism, the rotary encoder. Alright, so blue tack at the ready again. I'll do this one slightly differently. So I'll do a tack on the first one. I've got some more of these headers if it goes wrong, but the trouble with these headers is you can melt the plastic. So I wanted to tack the first one in and then make sure it was right, and see that slightly at an angle. So let's just tweak the angle. There you go. Only slightly burnt. Now that's the right angle. I'll solder the others and then come back and sort that blob out on the first one. Okay. That's still okay. Apart from that first one, still got a bit of a blob of solder on, but it's not that terrible. I just burnt one of the switches then. Right, okay, so that's that header on. Oh, now the next one, instructions strange. Remove resistor R30. Let irons down one pad of the resistor until solder on the other pad melts, and then remove the part. R30 is used to bypass switch 5, so the main board can be tested without the switch. Okay, so when I powered it up before, it was on. So that was R30, which is that. R30 is that one there. So interesting. So put on one pad until it moves to the other pad. And that come off? Yeah, I think that's come off. You can't see that, but okay. Take that resistor off there. I'll save it for later. There you go, R30. I forgive you for everything. Okay, so just looking at that, that's just left 2 pads on, which are now not joined. Right. Well, that was exciting. Now the resistors. No. I hope the resistors were all the same. They're not. My eyes aren't good. So this is going to be fun. So here are these little beasties. Suppose I can just go through with my component tester and test them that way, because I can't make out the colours very well. That is brown, black, red. Anyway, let's try using this little thing. Okay, so brown, black, red. Right, that's a 10K. So there's an 11K on the instructions, so it must be that one, and that's R4. So let's find R4. And these are going on the same side as the board as the surface mount are, so this is same as that. So R4. No, something I can't see any. Ah, there's your problem. Right. Step 2 is the analog board. Okay, makes more sense now. Right. So it's this second board now. So we've moved across to it. So R4 now should be a bit more easy to spot. So there's R5, R1 and 2, R3 and R4. So R4 is there. So let's pop him in. Now this is the worrying bit coming up. I'm going to do this one another way. So the last one that I have is R16, and R16 should be 150 ohm. This is where it all goes pear-shaped. 150 ohm then. Phew, yes, 152, that will do. Right, so that's all the resistors. Hopefully in their correct places, assuming that my eyes have seen the little silk screen on it correctly. But the fact that that's the one that's left implies I've done something right. Alright, so that's the resistors section over. Now the capacitors. Hey, and they're all different. Great. I thought the little ones would be the same, but not. So let's start with the smallest one. I can't see what that says on it, so let's just test it as usual. So that's 120 picofarad. So that's C6 or C7. There's C7. I'll get it while I can see it. C7, there you go. Oh dear, it's not good. Ooh, have I got a damaged part? Uh-oh, that's not good, unless my batteries are going. Try it with a different one. What's on it? Well, if this whole thing doesn't work, it just says 1 on it. And C4 is a 1 picofarad, so I'm going to risk that one. But if it doesn't work, then I know that that one's the one that's potentially to blame. Might just be too small for my meter to measure. Okay, that's the capacitors done. With that one, the potential problem if it doesn't work afterwards. Alright, now, I thought these weren't capacitors early. These are capacitive trimmers. There's C3 and C5, which are these two big ones here, so that should be easy. So C3, I'll do these one at a time. C3, C, and C5. Oops. Now the other slide switch. It should go next to that, which means this is going to be a pain to come out afterwards if it's a mistake. But anyway, if it's not a mistake, not if it's a mistake, if it is a faulty one. They don't seem to go in very far, but that's all right. Oops, too much there. Going to need to be socked away. I'm not really getting on with this solder sucker as much as I do with just having a wet sponge, which is what I always used to use. But I thought there'd be less thermal stress on the soldering iron tip if I used one of these, but who knows, maybe it's for a different thing. Not my best work. Okay. So now, electrolytic capacitors. These should be easier. I should be able to read these. So let's just have a look. So that is a 15 volt 100 UF. they're all the same anyway, so that's no problem. So I've just got to put all of these in, making sure that the long lead goes into the positive. Right, there we go. 5 little electrolytics. Next is the BNC connector, which is this beast. There's a lot of mass, thermal mass in this one. So I need to make sure that I can get it to warm up enough. So what I will do is let's pop something underneath that end of the board, set to keep them level, and then I'm going to solder the center tip on first to try and hold them in, and then give this one, put some more solder onto the iron to get good conductivity, and then put solder on the other side of the big pin to try and check that it's working. This is just sucking the heat away from the solder. You can see the solder's going. There you go. Just about going now. Let's do the other one. This one should be slightly quicker because the whole thing is heated up now. There we go. Okay. And I'm going to not touch that for a second, otherwise you will hear me scream. The next thing are the pin headers. So there's 2 of these pin headers. Looks like it's there and there. Still too hot. It's melted the blue tack as well, which is fun. Wow, it's made the blue tack hot. Never mind. Just cut that bit of the BNC off, give myself a bit of room. That is still hot blue tack. Okay, that's the one side done. And now the other one. A little bit of help with this one. With the blue tack. Now it's cooled down enough to hold. Okay, that is most of the soldering done. Still warm. So that's most of the soldering done now on this board. Some of it done very badly. I want to know what plugs into that. See what I've messed up. So it looks like this board, well, who knows, it plug in like that. Alright, so I might need to sort this out. It's slightly at an angle. And that's going to be fun. I'm going to leave that for now and see whether I can work it out when I plug it in. Otherwise I'm going to mess all of that up. Alright, so I think that's the end of my first bit of paper. It is finished. There you go. With a faulty capacitor and a bent header. now I've got to assemble the rotary encoder. So this should be relatively easy, but I could well muck it up. So, alright, here's an interesting thing. Please pay attention to the orientation of PCB. Use the side with the outline marking. Yeah, I get you. So that's the side with the outline marking. So what does that mean? Yeah, I think I've got to put this encoder on. So it's got 3 pins one side, 2 on the other, and then mounting pins. So I'll put that in there. Oops, not easy. There you go. I'm having to flex these side pins to get this in properly first. Right, that's it. You can tell when that's in okay. Let's just solder those on. Okay. Right, assemble the front module now. Fit the main board over while keeping LCD in place. This is where I have to unplug this, I suppose. Stick this on, I think. Off we come. Where I get it in the wrong position. Oh, there you go. That's on, whether I like it or not. Fold the main board over. Mount the rotary encoder. Okay. That goes through there. Oh, and straight in there. So those little pins on that header have come straight out the other side. That's useful. So it looks like I've got to solder those in. Do that quickly before it changes its mind. 1, 2. Oops. Done it now. 3. Just sort those middle ones out again. Too much solder again on my iron. Right. Mount the encoder board to it and solder the board to J2 of the main board. Oh well. Well, I've mounted it anyway. And I've soldered it to J2. But where are they? To the front plate with screws? Here we go then. So that must go on there. There you go. So that goes on there, and then I can screw it into there. Right, I get that. Alright, so it's looking the part now. I must put that on. Now, no matter what. Alright, so... Oh, now it asks me to check voltages. Well, now there's scary things to do on it. Alright, so I think I'm going to power it up. I've got to power it up. So I think that's it. I think physically I've sorted that now, although I still have to fit this in. So that must go attach the analog board to the main board, so that's this bit. Don't know what jumper 3 does. Alright, so jumper 3 doesn't attach to anything. Alright, so I think that's it done. So next, to find some power. Input 9.2 volts. So anyway, here we go. In we go. Nothing happens, but it might be turned off. Not bad. Running. Well, hey, there we are, an oscilloscope. Alright, so that's my oscilloscope built. I'm not going to do anything else with it now. I will do the calibration, and then I will build something to put a test signal into it, and we'll see what happens from there.